Hi, my name is Jonathan Kominsky, and I'm going to give a short presentation on the necessity-sufficiency model of causal judgment and how it explains the effects of norm violations on causal judgments, as published in Icard, Kominsky, and Knobe 2017 in Cognition. First, let's start with some very basic definitions. When we say that some cause X is necessary for some cause Y, what we mean is that if X had not occurred, Y would not have occurred. When we say that X is sufficient for Y, we mean that if X had occurred, Y would have occurred. Both of these are counterfactual conditional statements. Before going into the formal realization of the model, I find that it's useful to go through a sort of informal demonstration of it, and also to outline the effects that we're trying to explain. So let's say that you have two causes, A and C, that bring about some effect E. For starters, let's consider a conjunctive causal structure. In other words, both A and C are necessary to bring about the outcome. Under normal circumstances, if both A and C are norm-conforming, they both cause the outcome to some degree. We can think of this as a sort of baseline. And we can compare that against a case in which C commits a norm violation, in which C does something wrong, for example. Under our model, people consider a counterfactual possibility in which C does not occur, in which the norm violation does not occur. And in that counterfactual possibility, in this conjunctive causal structure, E also does not occur. This highlights the fact that C is necessary for E. Therefore, causal judgments of C are increased. We call this abnormal inflation. At the same time, we are contradicting the sufficiency of A in this counterfactual possibility. It is true that A occurs, but the outcome doesn't. So causal judgments of A are actually decreased. We call this causal superseding. Now, we can also consider a different causal structure, a disjunctive or overdetermined causal structure, in which A or C are each independently sufficient to bring about the outcome E. In the counterfactual possibility in which the norm violation does not occur, E still happens because A still happens. A's sufficiency is restored, therefore the causal superseding effect goes away. We call this no superseding with disjunction. However, we are now contradicting C's necessity, and causal judgments of C are actually reduced. We call this abnormal deflation. So these are the effects that the model was created to explain. Well, actually, the abnormal deflation effect is something the model predicted and then we tested. Originally, we didn't even think it would work. But let's now go through the formal realization of the model. In our model, when we use probabilities, they're not the probability of some event X happening. Rather, they are the probability of considering a counterfactual in which X is true. Our model is designed to capture the effect of the counterfactual possibilities that people consider on their causal judgments. However, there's an infinite set of counterfactual possibilities, so these probability terms are used to represent the likelihood of considering or sampling a subset that satisfies that condition. We can render the necessity and sufficiency of a given cause C in the following way using a do operator. The necessity of C is the likelihood of considering a possibility in which E does not occur, given that C does not occur. Given that is what the do operator is doing. It's setting the value of C in this particular case. The sufficiency is the same thing, except we're looking at the likelihood of considering a possibility in which E occurs, given that C also occurs. Conjunction and disjunction for this two-cause structure can be rendered as a minimum and maximum respectively. The likelihood of considering a possibility in which E occurs, given the value of C and A, is the minimum of C and A. If either of them is false, the outcome doesn't happen. In a disjunctive case, it's the maximum. If either of them is true, the outcome occurs. What we're interested in figuring out is causal strength. This is what our model estimates, the causal strength of a cause on a given effect. And to represent our norm violation, we will consider two different cases, which we'll represent as P1 and P2. And the only difference between them is that C commits a moral violation in P2, or any norm violation. And that means that people are less likely to consider counterfactual possibilities in which C occurs when it is a norm violation. P2C is less than P1C. That's all. Now here are the effects that we're looking to account for. In conjunctive cases, we have abnormal inflation and causal superseding, and in disjunctive cases, we have no superseding and abnormal deflation. So let's start with abnormal inflation. Here we're looking at the causal strength of C in particular, the one that commits the norm violation. This is how the model estimates the causal strength of C in the case where C does not commit a norm violation, P1. Here we have a sufficiency term, highlighted in green, and a necessity term highlighted in red. In both cases, these are the necessity and sufficiency terms that I showed you before, multiplied by the likelihood of considering a possibility that satisfies the do operator. So for sufficiency, that's the likelihood of considering a possibility in which C does actually occur. And for necessity, it's the likelihood of considering a possibility in which it doesn't, or 1 minus the likelihood of considering a possibility in which it does. Now, in a conjunctive causal structure, we can simplify both of these terms. For sufficiency, C is only sufficient in cases where A also occurs. In other words, the real sufficiency of C in a conjunctive scenario is simply the product of thinking about a possibility in which C occurs and thinking about a possibility in which A occurs, because it's only sufficient if both of those are true. As for the necessity, C is always necessary. If C doesn't happen, the outcome doesn't occur by definition. So it's just the likelihood of thinking about a possibility that satisfies the do operator. In other words, the likelihood of thinking about a possibility in which C does not occur. So now, with this simplified equation, we can compare the causal strength in the case where C is norm-conforming to the norm violation. And mathematically what happens is that the causal strength is greater when C violates a norm. Now, you might be thinking, wait a second, doesn't this decrease C's sufficiency? Because it's still in this equation, right? P2C multiplied by P2A, and this is true. But the effect on sufficiency is mitigated by the fact that it's multiplied by another probability. But the impact on necessity is direct. So as P2C gets smaller, the necessity of C increases, and therefore the causal strength of C increases. Thus, abnormal inflation. Causal superseding works very similarly, except we're now looking at the causal strength of A instead of C. But the math is exactly the same. We can simplify the equation in exactly the same way. And again, the only thing affected by the norm violation is the probability of thinking of a possibility in which C occurs, P2C. And because P2C is going to be less than P1C, the sufficiency term is going to be reduced in that case. A is less sufficient, therefore causal strength of A is reduced, causal superseding. Now when we get to disjunctive cases, things get a little more complicated. We're going to make an assumption, and there's one of two assumptions that you can make, but it doesn't matter, it works out the same. The assumption we're going to make is that we presented people with a case in which C did actually occur. And the reason for that is you can see that there's this value of C in the necessity term on the right, because the necessity of C is taken into account. Now, let's say we presented people with a case where C actually occurs. That works out to 1, and the necessity then works out to 0. Because if C actually occurs, it is never the case that E does not occur in this disjunctive causal structure. So the necessity term just goes away completely. As for the sufficiency, A is always going to be sufficient by definition. So the causal strength of A in this case is just the likelihood of thinking about a possibility in which A occurs. And because that's not affected by whatever C does, there's no causal superseding effect. Causal strength of A is the same in both cases. Now, of course, you could also make the assumption that we presented people with a case in which C doesn't occur, but it's still the case that the causal strength is unaffected. It's just that now the causal strength is 1 rather than the likelihood of thinking of a possibility in which A occurs. And once again, when we go to look at causal judgments of C, the math is exactly the same. As long as you assume that A is 1, and again it works out the same for A 0, what you get is there is no necessity term here at all, and the sufficiency is just the likelihood of thinking of a possibility in which C occurs, and from this it should be fairly obvious that because the likelihood of thinking of a possibility in which C occurs is less when C commits a norm violation, causal judgments of C should be reduced in these disjunctive cases. So that's the necessity-sufficiency model of causal judgment. On behalf of my co-authors, thank you very much for listening, and if you want to see more about the model, you can find the whole paper here.